Hi everybody, so we continue with Geometry and Trigonometry 1, which is Chapter 4, specifically with Section 4.4, Surface Area and Volume. So we start by looking at several shapes, their volumes and surface areas. So first we have a right or square pyramid. It's known as a square pyramid because its base is a square. The volume is going to be 1/3 the area of the base, or the square's area, times the height. The surface area is going to be the area of the base, which again is the square, plus the area of the four rectangles, so these areas here. Now it's important to notice that in order to find the surface areas of the triangles, we would probably have to find a height as well for each face. Well, actually all faces are the same, so once we find one height, we know what the others are. Now, next we have the right circular cone, and notice that basically the formula for the volume is the same as the formula for the volume of the pyramid, because it's 1/3 area of the base, pi r squared, times the height. Now, pi r squared, as you know, is the area of this base, the area of a circle. The surface area is the area of the base, or the circle, plus the area of the surroundings, so to speak. So notice that it's pi times radius times s, which is this line that we can find using Pythagoras. Then we have the sphere, and the volume of the sphere is 4/3 pi r cubed. Be careful, because one of the most common mistakes is that people use r squared, but it's r cubed for the volume. The surface area is 4 circles, or 4 pi r squared. For the cylinder, we have that the volume is going to be the area of the base times the height. Now the base is a circle, that's why it's pi r squared times the height. Then the surface area is going to be 2 times pi r squared. That's going to be the two areas of the circles, this circle and this circle, plus 2 pi r times the height, which would give you the surface area of the side. So we have three more shapes to look at. The cuboid, which is basically a box. The volume is going to be length times width times height. And then the surface area is going to be the sum of all the different surface areas, right? So notice that you would have 2 times length times width, which is going to be this area and this area, plus 2 times width times height, which is going to be this area and this area, plus 2 times length times height, which would be this here and the other surface that we would have in front of us. Then we have the triangular prism, and notice that the volume is the area of the base times the length. So this would be the length. The thing you have to be careful here is when you want to calculate the area of the base is actually this triangle. So it's the area of the triangle times the length. Then the surface area would be 2 times the area of the base, or the area of those two triangles, plus the area of the three rectangles, right? The hemisphere. So the hemisphere is simply half a sphere. So notice that everything is going to be half of what we were doing for the sphere. Instead of 4/3, it's going to be 2/3 pi r cubed. And instead of 4 pi r squared, it's going to be 2 times pi r squared, or 2 circles. So now we're going to do example 4.23. And it says, an ice cream cone has the shape of a right circular cone with radius 3 centimeters and a height of 8 centimeters. Part A, calculate the volume of the ice cream cone. So for the volume, we have that the volume of a cone is 1/3 pi r squared times the height. So notice that we have 1/3 times pi, the radius is 3, so 3 squared, times the height, which is 8. Plug this into the calculator, and it's going to give you approximately 75.4, and don't forget the correct units here, centimeters cubed. Volume is always going to be the unit cubed. For B, it says calculate the surface area. Now, we said that the surface area of a cone is equal to pi r squared, which is the base, plus pi times r times s. Now, but because this is a cone, we have to discard the area of the circular base because the cone is open. So it doesn't have a surface here, right? Okay, so we need pi times r times s. So we have r, but we don't have s. Now before I said we can use Pythagorean theorem to find s, since this is a right triangle here, as you can see. So that means that s squared is equal to 3 squared plus 8 squared. And that means that s is going to be the square root of 9 plus 64. And this is going to be the square root of 73. Now you want to leave this exact, because if you translate this into decimals, you are prone to make mistakes, since this number here is irrational and it has an infinite amount of decimals. So leave it as the square root of 73. Then we're ready for the surface area. The surface area is going to be pi times the radius, which we said is 3. So pi times 3 times the square root of 73. And then now we plug it into the calculator, and it's going to be 80.5 centimeters squared because it's a surface area. Now we round to 3 significant figures. So next we have example 4.24, and it says a spherical rubber ball has a radius of 10 centimeters. Calculate the volume and the surface area of the ball and interpret your answer. So first of all, we have the volume, and the volume of a sphere, remember, is equal to 4/3 pi r cubed. So in this case, the volume is going to be 4/3 pi times the radius cubed, which is 10 cubed. Plug it into the calculator, and it's going to be approximately 4,189, and the units, very important, centimeters cubed. Now it asks to interpret the answer. Well, one way to interpret the answer is that we would say that this represents the amount of air available inside the ball. Now for the surface area, remember that the surface area is 4 circles, so 4 pi r squared. And this is going to be 4 pi times 10 squared, which is approximately 1,257 centimeters squared. Now, one way to interpret this is saying that if the ball was made from a thin sheet of rubber, this would be the area of the rubber sheet out of which the ball was made. So next we have example 4.25, and it says a grain container has the shape of a cylinder with radius 3.5 meters and a height of 7 meters. The roof of the container is a hemisphere, as shown in figure 4.34. So we can see that here. Part A, find the volume of the entire grain container. So in this case, the volume is going to be equal to the volume of the cylinder, which is pi r squared times the height, plus the volume of a hemisphere, which is going to be 2/3 pi r cubed. Then all we have to do is substitute, and notice that this is going to give us that the volume is equal to pi times 3.5 squared times the height, which is 7 meters, plus 2/3 pi times radius cubed, so 3.5 cubed. Plug this into the calculator, and it's going to give you approximately 359 meters cubed. For part B, they want us to find the surface area of the grain container. Now here we have to consider two things. We don't need to find the area of the base of the cylinder, since this would be on the ground and it wouldn't be part of the surface area. Likewise, we don't need to calculate the other base of the cylinder, because that also is excluded from the surface area. So basically we need to find the area of the outer part of the cylinder. And recall that that is simply 2 pi r times the height. And then the surface area of a hemisphere is 2 times a circle, right? So 2 pi r squared. And then we substitute. So this is going to be 2 pi times 3.5 times 7 plus 2 pi times 3.5 squared. Plug this into the calculator, and it's going to give you approximately 231 meters squared. So next we have example 4.26, and it says a chocolate bar is in the shape of a right triangular prism as shown in figure 4.35. So we can see that here to the right. Part A, calculate the volume of the chocolate bar. So let's recall that the volume for a right triangular prism is equal to the area of the base times the length. Now we said before that the area of the base is the triangle, right? So this triangle, we need to find that area. Now since the area of a triangle is equal to 1/2 base times height, we don't have the height. So we need to find this height h. But notice that this here is a right angled triangle, and we have that this angle is 60 degrees. So we can use trigonometry in order to find the height. So we have to find the opposite and we have the adjacent. That means that we need to use tangent. So notice that tangent of 60 is equal to the height divided by 2, opposite over adjacent. Therefore, the height is going to be 2 times the tangent of 60. So that means that the height is approximately 3.46 centimeters. We would then have that the area of the triangle is going to equal 1/2 times 2 times 3.46. Let's use this that way. Looks better. And notice that this will give us 3.46 centimeters squared. So we have then that the volume of the right triangular prism is going to be 3.46 times the length, which is 5, right? Times 5. And this will be approximately 17.3 centimeters cubed. Okay, so now we're going to erase a little bit and do part B. So for part B, they want us to calculate the surface area of the chocolate bar. Now the surface area of the chocolate bar is going to be the sum of the surface areas of the different shapes that make up the chocolate bar. So recall that this height here is 3.46 centimeters. But also we know that the area of this triangle was 3.46 centimeters squared. And we have 2 of these triangles. We have this one and we have this one here. So that means that the surface area would equal 2 times 3.46 plus, let's say, this rectangle here. And that rectangle is going to be 2 times 5. So this plus 2 times 5 plus, let's see what else. We have also this rectangle that is in the front. Let's say this is the front. So this one would be 5 times 4 plus the rectangle that is to the back, which is 5 times 3.46. So now all we have to do is plug this into the calculator, and it's going to give us that the surface area is approximately 54.22 centimeters squared. So next we're going to do example 4.27, which will be the last one on this video. And it says, the Cheops Pyramid in Giza, Egypt, shown in figure 4.36, is a right square pyramid with a base length and width of 230 meters and a height of 147 meters. 3 of the base vertices are labeled B, C, and D, while the apex is labeled A. So this is the apex of the pyramid. The projection of the apex on the base is labeled O. So that is the projection right here, and this is O. And notice that AO is a height. Therefore, this here is a right angle. Part A, find the volume of the Cheops pyramid. So remember that the volume of a square-based pyramid is equal to 1/3 area of the base. So in this case, 230 squared, because it's a square, times the height, which is 147. And this is going to give us exactly 2,592,100 meters cubed. Okay. Part B says, find the length of the diagonal BD. So BD would be this diagonal here. But notice that since this is a square, it's the same as this other diagonal, right? And we can find that using the Pythagorean theorem because this is a right-angled triangle. So that means that BD is going to equal the square root of 2 times 230 squared. Because this is 230 squared plus 230 squared, which are the legs of this right-angled triangle. And then this is going to give us approximately 325 meters. For part C, they want us to find the length of AB. So AB is the hypotenuse of this triangle here, right? So notice that AB squared is equal to OB squared plus 147 squared, which is the height squared. So we need OB, but OB is just half of BD because this point here, O, is in the dead center of the square. So this divided by 2, so that means that AB is equal to the square root of 162.5 squared plus 147 squared. And we said this is AB, not A. So that means that AB is going to be approximately 219 meters. For part D, it says find the size of angle BAC and angle OBA. So let's start with angle BAC. So BAC, angle BAC is this one, BAC. Notice that we have this length, right? We just found it. This is 219 because it's the same as this one, which is also 219. So with this, we can find the angle BAC using the cosine rule, because notice that we can say that the inverse cosine of this angle is going to be A squared plus B squared minus C squared over 2 times A times B. So in this case, A is and B are the same. That's 219. So it's going to be 2 times 219 squared minus C squared, which is going to be 230 squared. This divided by 2 times A times B. So 2 times 219 times 219. So you want to plug this whole thing into the calculator. Notice that this is going to give you approximately 63 degrees. So that's this angle here, 63 degrees. They also want us to find angle OBA. So angle OBA. OBA. So where is OBA? OBA is this angle here. So notice that we have OB. We said that OB is 162.5. So let's write this over here. OB is 162.5. And we have also the height. We have also the hypotenuse. So we can use any trigonometric ratio for this. In this case, let's use sine. And because we want to find the angle, we can use inverse sine. So this is going to be the inverse sine and opposite angle OBA is the height, which is 147. So 147 divided by the hypotenuse, which is 219. So this is going to give us approximately 42 degrees. So this here is 42 degrees. Okay, so I'm going to erase a little in order to solve part E. So for part E, it says, hence, find the area of triangle ABC and the lateral area of the Cheops pyramid. And it says the lateral area is the total area of the triangular faces of the pyramid. So that would be 4 times the area of triangle ABC. For this, we can use that rule. Remember that if we have an angle that is between two known sides, we can use the formula that says that the area of the triangle is equal to 1/2 A times B times the sine of the enclosed angle. So in this case, it's going to be that the area is 1/2 times A times B, but A and B are the same, so that's going to be 219 squared times the sine of the angle, which in this case is 63 degrees, so sine of 63. And this is going to give us approximately 21,367 meters squared. Okay. And then finally, the total lateral area is going to be 4 times the area of this face, right? 4 times 21,367, and this is going to equal 85,468 meters squared.